Hi calculus students! Welcome to our next learning target, which is properties of definite integrals and accumulation functions. So as you can see, we are continuing to learn more about definite integrals. We're going to learn about different properties and how to use them. And then we're also learning about this thing called the accumulation function. Right here, this vocabulary word. And so this section is similar to the last one in that we'll be finding areas under functions, but rather than use Riemann sums and trapezoids, rectangles and trapezoids, to estimate the area, you can see we will actually be able to find the exact area using geometric shapes. So this graph is really just composed of a square and two triangles, which we are capable of finding the area of. So instead of estimating what the area is, we will actually be able to find the area under the curves in this section. All right. So let's go to our notes, starting with this page right here. And I just want you to be able to have some sort of focus for these notes. So let's write this at the top, what our focus is for this video is going to be, so our focus is definite integrals as net accumulation. So there's that word again, accumulation. And what we mean by net accumulation is that this can be a positive value or it can be a negative value. So as the sentence below this says, all of the functions that we've dealt with so far have been non-negative, but this isn't always the case. So right now we're going to kind of concentrate on learning about how non-negative functions, so functions that are above the x-axis, are different than when the function is negative, meaning it's below the x-intercept. So let's start with positive, non-negative functions first, which is what we're more familiar with. So what this says is that if we have a non-negative integral or non-negative function and we take the integral of it, then A, the area, so that's A, oopsie daisy, A is going to be equal to the definite integral from A to B. So what this looks like visually is I have a function from A to B, and this function is positive. It's non-negative, so I don't know what it looks like, but I know that it's non-negative. Then I can say that the area here is right here. This is a positive value. Okay? And that represents the area. It's going to be a little bit different when I have a function that is negative. So let's go from A to B again. But now instead of drawing a non-negative function, let's draw a negative function. So that just means it's below the x-axis. Now when I take the definite integral, I would actually get a negative number. So the definite integral will give me a negative number. And I want you to consider, so far we've been saying that the definite integral is the area under the curve. Does it make sense for area to be a negative value? Like for instance, if I am building a fence and I want to find the area of a fencing that I'm going to use for my backyard, would it be possible for me to get an area of negative 50 square feet? Negative 50 square feet? Does that make sense? I think you can tell from the tone of my voice that that does not make sense. And so that is why we have this equation over here, that when I am trying to find the area of a negative function, I have to add this little negative sign. Because as you know, two negatives make a positive. So if my definite integral ends up being negative, like we can see over here, we add the negative sign in the front to turn it positive, so that our area comes out as a positive value. Okay? So this is kind of the big idea that this video is going to be about, thinking that some definite integrals are going to come out negative, and we might have to do some manipulation if we're finding the area to make it positive. So I want you to pause me and just read this little section real quick, and then I will summarize it for you. So go ahead and just read this little bit. Okay, so assuming that you've read it, I just want to give you a little summary of how I would state this. So basically, this is saying the integral, let's zoom in, the integral will give us negative values even if area cannot be negative. So basically the definite integral doesn't care about that area is not negative. The definite integral is going to say this value is under the x-axis. It is a negative value. But if we as humans are trying to think about it as area, we have to be smart enough to say, okay, definite integral, you gave me a negative value. I'm going to put a negative sign in front of it to make it positive. Okay? All right. So looking at what this means graphically, as you can see here, we just have like some sort of parabola shape in this graph, some sort of parabola. And so this integral, which normally we would just say this is the integral from like -5 to 5 of f of x dx, right? Where I start at -5 and I end at 5. Oh, why did I say -5? I meant to say, oopsies. I meant to say that -5 is our start, and then +5 is where we end. So if I'm taking the integral from -5 to 5, this is how I would write it. But if I'm trying to find the area under the curve of these three sections, I would need to split it up into these three integrals. And the reason why is because in the middle here, we can see that we have a negative integral. Okay, so between -2 and 3, the integral becomes negative. And so this is one where I would have to apply two negative values to make it positive if I wanted to find the area. Okay, so this is just showing you what a positive area looks like, things that are above the x-axis, and what a negative area looks like, things that are below. Cool. The graph on the next page looks super similar, but you might notice, hey, what the heck, why are they calling this negative and this negative, and then what's down here positive? What? I thought we just learned the opposite thing over here, right? That's the opposite. So basically what is different is this integral is going from right to left. So this is essentially saying, I'll write the integral at the top. Instead of going from -5 to +5, what they did instead is they did the, oopsies, I always do that. They take the integral from 5 to -5 of f of x dx. So this is saying now start at +5 and end at -5. So this is starting over here and going this way to -5. So if we have an integral that kind of goes from right to left instead, all of our positive and negatives get switched. So if I start here and go this way, even though it's above the x-axis, since we're going backwards, it becomes negative. And then I continue this way, even though this integral is below the x-axis, because I'm going backwards, it becomes positive. And then same thing with this last one. Since I'm going backwards, even though this is above the x-axis, it becomes positive. So this kind of becomes shortened right here in this equation. Okay, so it says if I go, instead of from A to B, if I go from B to A, then that will essentially make the integral negative. So if I switch the direction, then the integral will become negative. So that's one big property of integrals that we just learned, okay? The highlight of this video, if you take away anything, should be this. Area is always positive, area is always positive. So that no matter what I get from my definite integral, if I'm trying to find the area, then I need to change whatever I got in the definite integral to be positive, okay? And a trick that we're going to use is something that we kind of looked at on the previous page. So sometimes that means we're going to have to split our definite integral up into two, okay? Sometimes that means we're going to have to split things up into two, which is what we did on this previous page. So on this previous page, let's say I wanted to find the area of this. I'm going to use the two properties that I just highlighted to find the area. So my area is going to be equal to this first section from -5 to -2 of f of x dx. And then I'm going to add it, or not add, because the next one is negative, I'm going to subtract from -2 to 3 of f of x dx. And then I will add it with 3 to 5 of f of x dx. Okay, so if I wanted the area, I am using the properties on the next page, those two properties that I highlighted, and this is what I had to do. So I had to split it up, and I had to make one of them negative since the integral ended up being negative. But if I did all this, this would give me the area of the shaded region up there. Okay, this is the end of this video. If this was a little bit confusing, please read. Note that I did not read everything with you, so take the time to read things on your own and fully digest these notes.